Hello, explorers of the atomic world. Today we're going to unveil the secrets of the atom by decoding their properties. Let's dive into the essentials. All right, first of all, let's talk about what the atomic number is. Basically, it's the total number of protons in an atom, and it never changes. It's what defines an element. So if you take a look at the periodic table, you're always going to notice that the atomic number pretty much is always right above the symbol and or the name. It also shows us the number of protons. Uh, Here's another shot with another one from the periodic table, but this one's, let's take a look at the atomic mass. Atomic mass is the total number of protons and neutrons in an atom. Their number can change because of isotopes, and we're going to get into isotopes later, but isotopes have a different number of neutrons. So here's a couple of ways that we can express the mass number and the atomic number. We'll see these later on, and you don't necessarily have to worry about this right now, but you will see it on some worksheets and things like that. Mass number, so they're putting the mass number on top this time and the atomic number underneath. Mass number on top, atomic number underneath. So, all right. Um, in a neutral atom, atoms are neutral by definition. How many electrons are there? So the number of protons and the number of electrons are going to be equal to each other. The positives and the negatives will cancel each other out. If an atom has a positive charge, what happens is it loses one electron or loses one negative charge and it becomes positively charged. Okay, it's off balance. For every negative charge, we're adding one more electron to it. Here's some ways that you can take a look at and see that we have symbols. Sometimes it's if you taking a look at the way that we saw it before with the mass number and the atomic number, and then the charge. The 2 minus charge means that you have two extra electrons. Lithium is a +1 charge. That means you have one less electron than it normally would. All right, some examples here. Take a look. So carbon, in this case, the atomic number is 6, so that means I have 6 protons. The mass number is 12. The protons plus the neutrons equals 12. In this case, the neutrons is 12. Since it's neutral, it also is going to have this 6 electrons. Okay, let's take a look at a different one here. This is what we call carbon 14. Carbon 14 is an isotope, so there's a different mass. In this case, the atomic mass is 14, so the number of neutrons changes. Mass is protons plus neutrons. We have the mass of 14, which is what that number is right there, equals 6 plus the number of neutrons. So the number of neutrons equals 8. And taking a look at the ion here, taking a look at an ion of carbon, the charge is different. Here we have a -4 charge. In this case, it's a -4 charge. And since it is negative, we add electrons to the proton number. The proton number is 6. We're adding that 4 because of the -4 charge here to get 10 electrons total. So atoms are neutral. We have the same number of electrons as protons. Ions are charged particles. Negative ions add more electrons, and positive ions take away more electrons. And then isotope is an atom that has the same number of protons but a different number of neutrons.